Okay, so we'll look at example 1. And example 1 is how to determine a particular term of the series. Okay, a visual and performing arts group wants to hire a community events leader. The person will be paid $12 for the first hour, $19 for 2 hours of work, $26 for 3 hours of work, and so on. Okay, so what we have is a pattern. Okay, obviously we can't do anything with an arithmetic sequence until we prove that it is indeed an arithmetic sequence. So let's write out the terms. Our first term, that would be t sub 1, is 12. Okay, then we have 19, and then we have 26. Okay, so this is the first term, this is the second term, this is the third term, and so on. Okay, and so on, meaning it continues to follow this pattern. And what is the pattern? Well, if we look at this, we can see that each time we're always adding the same amount. We're always adding 7. Okay? So we know that we're going to be able to get to any term in the series just by adding some multiple of 7. Okay? So we can see that our first term, okay, we have T1. So T1 is equal to 12. Okay, that's one of the things that we're going to use in our formula. We have D, which is the common difference, and that's 7 because we're going up by 7 always to get from one term to the next term. And when we do question A, we're looking for a general term that you could use to determine the pay for any number of hours worked. Okay, so we want to keep n as a variable. Okay, so we're going to write for A, we want to write T sub n in terms of n. Okay, meaning that we're not going to expect a number as an answer, we're going to express an expression with an n in it. Okay, so let's try this. We'll use our formula. Okay, and so we know, and I'll just, as I write the formula, I'll just kind of explain what it means. We know that the nth term, T sub n, will always be obtained by taking the first term and adding, okay, remember we don't want to add n times the common difference, okay? We want to add n minus 1 times the common difference, right? Because to get to the second term, we only had to add d once. To get to the third term, we had to add it twice. So it's always n minus 1. Okay, and so remember, we're going to keep this as a variable. We're going to keep this as a variable. We're going to keep this as a variable. And what we want to do is we just want to substitute numbers in for t sub 1 and for d. Okay, so we take t sub n, leave it as it is. Okay, our first term we know is 12. Okay, and n minus 1, and the common difference is 7. Okay, now that's a good way to leave it, not the way that they're looking for, where they just want it written as a nice linear equation. But what we have here is, it says quite easily, we're going to find the nth term of our series by taking 12 and adding 1 less than n, okay, n minus 1 sevens, okay. But to make it nice, what we're going to do, we're just going to expand that 7. We'll just distribute that 7. So we'll go 12 plus, I'm just going to distribute, and that's going to be 7n. And don't forget to distribute the negative there. Okay, and we'll just write it as 7n plus 5. So it's a nice linear equation, okay, with the n term first and the constant term after. Okay, so for any number of hours, we're always going to be able to figure it out, figure out how much we'd have to pay using this equation. Okay, so if it's 10 hours, that'll be 70 plus 5. That's 75 hours. Okay, and we can do that. Let's check it. For 3 hours, okay, 7 times 3 is 21, plus 5 is 26. Okay, so we know that it works. We've tested it out for these ones. That's a nice, answer right there. Okay, so that's generally for any n, we can find the nth term. Okay, so that's what they ask us for in A. How much will the person be paid for 6 hours of work? Well, in this case, we're actually taking an n that's known. Okay, so we know that we're looking at 6 hours, right? Because each of those terms, remember, that's going to correspond to a certain number of hours. So this is 1 hour, 2 hours, 3 hours for the first term, the second term, and the third term. So for 6 hours, we're looking for the 6th term. Okay, so we're going to know that t sub 6 is going to be given by 7 times 6 plus 5, okay, because we've shown that this equation works for any n. Okay, so t sub 6 is going to be equal to 42 plus 5. Okay, that's going to be 47. Okay, and because it's kind of a real world problem, we're going to write our answer as a sentence. Okay, what will the person get paid for 6 hours of work? The person is paid $47 for 6 hours of work. Okay, and looking back to our equation, we can see that they're always paid $7 an hour plus an extra 5. Okay, so that's how we do it.